Alright everybody, welcome today. This is going to be one of our shorter lessons and probably one of our easier concepts to master that we're going to do. Before we get started, I do want to tell you that this is a great application of criterion B, or investigating patterns. Because we're working on a distance learning plan, I'm not going to have you do this as an assessment, but you might think about the ways that you could try to prove some of the things that we are describing and talking about here, because this is exactly what criterion B is really all about. Using patterns to create rules that we can use in mathematics in lots of different situations. So with that, let's go ahead and get started and talk a little bit about multiplication and division rules. And these rules are going to apply specifically when we start talking about negative numbers as well. So let's review quickly what multiplication means. If I have a statement like 3 times 5, that tells me that I have 3 5 times, or it's a more efficient way of writing 3 plus 3 plus 3 plus 3 plus 3. I also might even want to represent that visually, especially if I'm trying to prove something. That visual representation often will help, so maybe I put some dots down below. And we all know that 3 times 5, or 3 plus 3 plus 3 plus 3 plus 3, or my accumulation of dots, all equal 15. So all of these situations equal 15. But we want to start investigating what happens as we start to multiply with negative numbers. Well, if I take a look at a similar equation, but that's been slightly changed, we're going to see if we can think about what it might mean. So instead of having 3 times 5, if I have negative 3 times 5, we should be able to apply our knowledge and recognize that that should mean negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3. And using that knowledge and our knowledge of how we add integers together, we should still know that that's equal to negative 15. And again, I might want to represent that visually by showing some negative signs, and I could count up all of those negative signs and indeed see that there are 15 negative signs. Again, if we think about applying some patterns, we've already started to determine one of our multiplication rules. But we want to see if we can apply that in a different way as well. So I'm going to use this same exact problem, but I'm going to apply the commutative property of multiplication, which tells me the order that my multiplication problem comes in doesn't matter, that the answer should be the same. And we all know that. We all know that 3 times 5 is the same thing as 5 times 3. Well, let's take a look at that with this example. If I have negative 3 times 5, we knew that my answer was equal to negative 15. So that means if I have 5 times negative 3, my answer should also be equal to negative 15. Now we're moving into our multiplication rules. So we saw that if I had a positive number times by a negative number, I ended up with a negative answer. We also saw that if I had a negative number and I times that with a positive number, according to my my commutative property of multiplication, I'm going to also end up with a negative number. If you're not quite sure about either of those things, I would encourage you to practice and do some of those on your own and start with some simple problems and draw some diagrams out. Maybe try negative 4 times 3 and negative 4 times 2 and negative 4 times 5 and see what you end up with in all those different situations. And then flip them around and practice that out. So we've already learned 2 of our properties of multiplication, and that's that a positive times a negative is equal to a negative, and a negative times a positive is equal to a positive. Well, you came into this lesson already knowing the first rule to multiplication, and that is that a positive times a positive is also equal to a negative. Now, if we were doing a criterion B assessment right now, I would have you do a little bit of investigating on your own and see if you could prove what a negative times a negative would equal. But since we're working remotely, in this case, I'm going to just help you out and give you some information that a negative number times another negative number would be equal to a positive number. So with that, we have all 4 of our multiplication rules. And since we know that multiplication and division are inverse operations of each other, we know that these same exact rules are going to apply if I change my multiplication symbol to a division symbol. So let's go ahead and explore what that rule actually is. That rule says when multiplying or dividing, if my signs are the same, like I have a positive and a positive, my answer is also going to equal a positive. And if my signs are negative and a negative, my answer will also equal a negative. But this rule also says if my signs are different, then that means that my answer is going to always equal a negative. So let's apply this right now to a couple different practice problems just so you can see this in action. So I'm going to keep my problem over here. When multiplying or dividing, if signs are the same, the answer is positive, and if signs are different, my answer is negative. So here I have negative 3 times 4. Well, 3 times 4 is equal to 12, and then I need to look if my signs are the same or different. I see one negative sign with 3, and I see a positive number with 4. So that tells me my signs are different, so my answer should be negative 12. Let's try another one. If I had 5 times 6, we all know that that's equal to 30. And then I might think about if my signs are the same or my signs are different. In this case, my signs are the same. They're both positive numbers, so I end up with positive 30. Let's look at my next one. If I have negative 6 times negative 7, well, negative 6 times negative 7 is equal to 42, and I notice that I have 2 negative signs there. My signs are the same. That means that my answer should remain a positive answer. And finally, if I looked at a problem like 12 times negative 3, I would notice that 12 times 3 is equal to 36. And I had positive 12 and negative 3. Therefore, my answer would be negative 36. In all of these examples, we're just following those rules. And remember that these same rules apply with division. So we could have written division problems that looked very similar, and they would have the same result. With that, I hope you get to practice these multiplication and division rules with our positive and negative numbers. As always, let me know if you have some questions, and good luck.